I'm going to steal a bunch of content from last year and give updates from my presentation last year, and try to pay homage to some other people and projects. See how that goes. That sounds good. All right. So, and I'm also going to do that annoying presentation thing that I did last year, and I think it made one person nauseous. So, if you get like car sick really easily or something, when I go to change slides, just close your eyes for a second. All right, so. There we go. Okay, you get the idea. So now, prepare yourself for when I put between three. Okay, so info and data updates. I'll try to sort of explain some trajectories of different sort of data management and data accessibility things that we're doing. I also wanted to sort of start off with that. I feel like I kind of shoved this sort of GIS perspective down a bunch of people's throats, and I don't always know that that's sort of what people are wanting or what they're needing. So I feel like I'm kind of like a carpenter asked to do like a plumber's job. Like I know how to use the hammer, but maybe the hammer's not the right tool to fix the plumbing problem. So, if at any point in time we're talking about data, we're talking about management, we're talking about visualization, we're talking about analysis, and I say, oh, we can do that in GIS, and you're like, just back up a second. Not what I'm asking you. I know that's what you feel comfortable in doing, but I'm asking you to help me structure this data so that I can put it into R, something like that. So sort of just have that perspective that sort of that's the lens that I'm always sort of viewing things through, because that's what I feel most comfortable in. But if that's not what you want or what you need, that's not my only job is to do GIS work for the station or for your research project. All right, here we go. Change the focus. So let's zoom into the field station. We'll go up north and then we'll come back down here for a little bit. So everybody wants to talk about drones. So I just want to get it out of the way quick here to start with. So last year we flew a couple drones at a couple different sites, and some of them the FAA would have been very proud of our process, and some of them the FAA might not have been as proud of our process. But it's a learning, fluid, adaptive sort of legal environment. Some people would say that it's not a legal environment.
I think you can hit allow and get rid of that.
All right, so there we go. Okay. So so drones are the future, but they're not a panacea. They're not going to help you collect all the data that you want and do all the cool stuff that you think they can possibly do. There's a lot of logistical and real actual limitations to what you can do with a drone. So I just want to sort of touch base on some of those and keep that in mind as you're thinking about how they might be used in the future. So this is a flight over Colonial Point from last summer. And the really, really neat part about this is that you can start to see the beech bark dieback in the forest there. So all of those like weird little ghost white spots, those are all beech trees that have died. And those are the crowns without any. You can also see a lot of heterogeneity of what's growing out there in terms of size, in terms of canopy structure. So there's a lot of neat things that can happen. One of the things that we ran into as a difficulty with this site is that we wanted to use a drone to give us canopy structure. So, but what we realized was with the camera that we had, we couldn't get canopy structure unless we flew it at about like 700 feet high, which is about 300 feet higher than what's legal to fly a drone. And we didn't do that, but so we made do with what the data that we had, but because of the pixel resolution, because of moving leaves in the canopy when you're even on a pretty windless day, the canopy is still slightly swayed, and so that pixel registration needs to happen to be able to line things up and create these 3D models. You need a lower resolution camera to be able to do something like that at the sort of max height that you're able to fly these things at. And so we ran into some real actual sort of limitations for doing the kind of stuff we wanted to. We should have put a $50 camera on the drone, and that would have helped. So I also want to sort of talk about sort of the real sort of legal kind of stuff. So some of you might have heard that the FAA wants all drones to be registered through their website, and they make it a really easy process, and it only costs $5, just like it only costs $5 to register your Cessna. And so they're getting pretty serious, and they are starting to sort of litigate against people who are using drones who haven't applied for the proper permitting through the FAA for business purposes. If you're recreationally using a drone, then you register through the FAA and you go out and you be a cowboy somewhere. But if you go out and be a cowboy somewhere and then you go and you sell that imagery to someone, or probably more importantly, you go back to the lab and you process that imagery data and then you use it to publish something neat, then that's using it for a business purpose, and that would be a no-no from the FAA. So what we've done at the University of Michigan is we've tried to sort of get out ahead of that, and we've applied for a Section 333, and this is so jargony, and I really apologize. But so the take-home point of that is that Newt and I sat on a committee, and we worked hard to get the biostation included as a test site under this sort of blanket permit for the University of Michigan. And so that means that if you want to go out, say, the end of this summer, probably more practically like a year from now, if you want to go out and fly a drone under 200 feet, unless you're within 5 feet of or 5 miles of the airport, you don't have to call anyone and let them know. You don't have to apply for any special permitting. You're using a drone at our test site. If you need to go above that 200-foot hard cap between the 200 and 400 feet to do the type of sensing that you need to do, you still have to apply for a certificate of authorization or a COA through the FAA. But so I put this here because this is our Section 333, and it was submitted in September. It got posted on the website in end of October and still pending sort of review and blessing from the FAA. Yes, sir.
Does that include Sugar Island?
Yes. Yeah. Okay. It's I mean, if you guys have some really cool sites in Canada you want to go fly a drone at, let's go to that. It'd be a lot easier. From a legal perspective. But so we don't know when we're actually going to get this from the FAA. But hopefully we get it before the summer. So for those of you who are planning to go out and purchase a drone to collect aerial photography or to put some sort of chemical sniffer on it and go fly up in the air somewhere, hopefully those things will be a reality under 200 feet this summer. But I can't make any promise.
Jason?
Yes, sir.
Do those regulations apply to balloons?
So the FAA has their own they have a whole different set of regulations that apply to a balloon. And basically with a balloon that's 6 feet or less in diameter and has a payload less than 10 pounds, which you can't get 10 pounds up with a helium balloon that size, and it's tethered to the ground, you can pretty much do anything you want under 400 feet, which is what I've done the last 2 summers. With mixed results. All right, so this is another drone flight that we did this past summer, and this is at Sheboygan Marsh. This is the work that Shane's been super stoked about. And I just sort of want to show that while I feel like I'm putting up a bunch of barriers, there's some really neat stuff that you can do with it. And so this is not an oblique image, in Google Earth you can go oblique and you can see some weird abstraction of your house. This is actually all flown from above, and then a 3D surface is generated from those overlapping images taken by the drone. And then we can pan and zoom and do anything we want. and we can get height and we get structure from what's called, the structure for motion software, photogrammatic software that allows us to do this sort of thing. So we actually, with RU money last year, purchased the software to be able to do this. And so if we have overlapping drone or balloon aerial photography, we can start to create 3D structures and 3D models from that photography. So they have the capacity to do this. The other thing I want to say at the very beginning was that, so everything I'll talk about today is not about sort of like, hey, look what we did. It's about, these are real resources that are available for use in research and for collaboration. So, nothing here is intended to sort of say, like, this is a project that's mine and I'm taking care of it. This is everything I'm showing is, this is data for you to use for research. This is a project you can plug into. Any questions about this or any? Yes, sir.
So, Jason, that's obviously a false color image. Is there value in that?
So the weird thing about the drone that we flew was we wanted color infrared because we're interested in vegetation, right? But the sensor at the time that flew on the particular drone that we were using, they only did an RGB camera and then just a one-band infrared collect. And so the idea was that you were trying to fly them as close to possible or as soon in time as possible, and then you would stack those images together. But the problem was they're different spatial resolutions. And so the high resolution RGB photo, you couldn't get those pixels to match. But the lower resolution infrared, you could get them to match, you could create structure. So yeah, so you can see that the uncut plot of Typha there, and we actually get an actual height value difference between the cut area and the uncut area. We measure the heights of the shrubs that are in there, the different. And what's, all right, I will walk down there. All right, so I talked about this a couple times now. Newt and myself, we got a grant through the New Initiatives, New Infrastructure Grant through the Instructional Support Services to pay for iPads for the field station and to pay for some programming assistance to create a transcription site for digitizing collections. And so as of last year, we had, I think, like 30 labels digitized, and now we're up to about 4,000 labels digitized from the herbarium, which is great. And the other neat thing about this is that this is no longer sort of, on a computer that I give you access to. This summer, you tell a student to go to a website, that website down below, they go to the Transcribe website, they create a login for the biostation. If they've already created a login, they just have to log in with that. It's not tied to their unique name, but it's the login that everyone does when they apply for housing or a research application. And then we can tie the digitization of those labels to the student or to the researcher at the PI. So I really hope that this could be a resource just for classes. As this is a fun thing to expose people to herbarium specimens. Because what happens is that you look at a label and you're like, oh, this label doesn't make any sense because it's written in 1919 and I can't read it. So then we actually get them into the herbarium to look at herbarium sheets. And we can sort of adapt this to do other collections. So we can do insect collections. We want to do the parasite slide collection. So the first step is actually digitizing the actual, taking pictures of the labels of the physical specimens, and then we can put this up on the web for it to be crowdsourced and digitized. So the second part of the grant was to get technology into the field for students to use. And so we have, we bought 10 iPads, and instead of buying more iPads, well, let me take it back. So ISS said, oh, that's a cool idea what you guys did. We'll do the same thing for down here. And so they bought 30 iPads for their office down here, and we're going to be able to take some up with us next year. So we'll have 16 to 20 iPads at the field station next year to be used for classes and research. So why use the iPads in the field? It's not to check Facebook. It's to map observations and collections in the field. So last summer, so Brian's class and Phil Meyer's class was the initial sort of painful pilot project in 2014. 2015 worked pretty good for most things. 5 classes and multiple REU students used it. We probably generated about 475 to 500 unique records or observations of specimens or a location where people did some sampling, those types of things. And so those are all, they they're on the iPad in the field for the students, but then when they get back and they press the sync button, then they have it in a web map, and they can start to do analysis on that for class. So also the other sort of big hairy thing that I get excited about is we flew a LiDAR flight last year in the spring, and then the vendor, the contractor who flew that flight, took a long time to process that data, but I'm glad that they did a good job processing the data. So we have actual LiDAR for the entire field station. So if we had gone out and we had tried to get this on our own, it would have been probably like $60,000 to $70,000, but we paid like a good night at the Douglas Lake Bar worth of money for this because we piggybacked. Yes. What? So we piggybacked on another project and we were able to get our 10,000 acres below the bridge flown this spring. And so we now have for all of the UMBS in holdings and then all of the private property sort of in between those those lands that we manage and own, we have very high resolution digital elevation model, so 1 foot elevation model. So it's a pretty amazing data set. It's super huge and clunky, and so it's hard to transfer it to people. It's hard to view it. You need a decent processor and you need enough RAM on your machine to interact with the data as a whole, but we can chunk it up for your particular interest. And so, if you're just interested in the bird plots, just interested in Honeysuckle Creek, we can chunk it up and give it to you like that. Yes, Steve?
Digital elevation.
So a digital elevation model is what's that?
Electronic complement.
Yeah, it's a topographic map. So this rasterized image here is all based on so the plane flies over, they shoot a laser down to the ground, and then that laser pulse that returns, and then subsequently later gets classified as a ground return. You scrub those all from the entire LiDAR point cloud, and then you use just those points to create a very detailed surface model or topo map.
There was a reflection off of the highest, the first thing.
Well, no, but yes.
Okay. So is it ground or canopy top?
So it's ground. So this is the cool thing about LiDAR is that it penetrates. Okay, sorry. Wasn't going to do it, but I'll do it. Okay, so LiDAR is not a passive remote sensing technique. It's an active. So it's sending out information and getting it back like a state trooper on the highway. And so it's not like passive reflection like a photo. And so it sends out a pulse, and it can tell you the first thing it hit, some intermediate range, and then the last thing that it hit. And so when they get these point clouds back and the vendor processes them, they have some fancy software that will say, okay, all of these points in this crazy point cloud are ground points because they were the last thing to come back from this pulse that was sent down. And the first thing that was sent is a first return or an unclassified point, and then you can sort of take the difference of those to get canopy structure or building heights or things like that. All right, so last year I was like, we're going to get spring, but we really want to think about getting summer because summer would be so much better, and summer is what they did in 2009. And, it allows us to do really cool stuff like map tree canopies and distinguish between structures and things like that. I don't know that we actually really need to do that. So this is from the spring, and this is the burn plots, as some of you can recognize. And I think for the level of specificity that we need for most projects, like this is going to be in the sweet spot for being able to look at canopy structure, for the type of metrics and the type of things that people want to do for their research. So great. All right, so on the left, that's the 98 burn plot. On the right, that's the 80 burn plot. On the north end, that's the deer exclosure. So here's the 98 burn plot from the, so you take a slice of that point cloud, and you can look at the ground point along the ground, and then you can look at the canopy structure there. And so you can measure all of those heights of that LiDAR point cloud. So I can tell you, the ground is at 220 meters, and that shrub is at 223 meters, and that tree is at 210 meters. So I think it's pretty powerful, and I really hope that it's useful for research. One of the unexpected things that came out of processing the elevation model is that, and this will probably be the first thing that gets published from this data set, is that you can use this super high resolution digital elevation model to find cache pits. So this like cluster kind of right here, and then a cluster right there. Those are. It's not working.
It's not working?
I think the battery's dead. So Megan Howey and some researchers from the University of New Hampshire are actively, they've done a bunch of work, and they're going to either work with Luke and myself, or they're going to actually send someone up this summer to look at, are these cache pits, or are they pit and mound topography? And can we use algorithms to search the entire landscape to find other anthropogenic uses on the landscape? I'm not going to tell you what this is because I'm going out there to part of that. And I do this in here because Carrie loves this. So this is sort of the more sort of like science and the art of using data. So this is right along the lake right there. You can even, what's even fun is you can even see like the roof of the No. You can see the roof of the fire extinguisher housing.
Oh, yeah.
It's height. Yeah, it's all it is height. All right, so I also wanted to sort of give a quick update on management plan that we talked about last year. Kyle Anderson gave a big presentation. We gave a bunch of information during the field season. We where to find it. We then subsequently worked with Michigan Tech University and their forestry capstone course to go out and do a bunch of data collection and do some recommendations on particularly on forest management options that the station might have. And so that's led to there is going to be some timber management work done in the extreme southwest corner over there along Riggsville Road and south. And so I've already delved too deep into too many other things, but I'll just say that we're using it as a guiding document. It was great to have a better understanding of the implication of forestry practices historically at the station, either through actual forestry practices or through forestry science done here at the University of Michigan. And then sort of this idea that how do we then carry that sort of legacy of forestry and forward into the future with the type of research questions and the type of research funding opportunities that we have. And so we know very specifically where forest management practices have been done historically, where planting had been done, where there's natural regeneration from fire. We have a lot more robust of a data set in terms of land use history than we had before, or maybe I should say it's accessible now to people. So if your research questions are more about sort of land use history and the impacts of management, historic management, future management, the idea of perhaps introducing a manipulation, this is sort of where we're going. And so what in here is, this sort of inviolate, research preserve, experimental timber sale area, this is all sort of theoretical, but we've set up a process and a structure for evaluating project by project. We're not saying that all of those lands will be cut. We're saying that in terms of land use history, existing research footprints, and the vegetation that grows there, that those might be appropriate places to do some type of research manipulation that is about forestry. These aren't lands that are in experimental and timber sales. Those aren't lands we're going to be cutting to make money. Those are lands where a manipulation that involves some sort of forest manipulation, timber related, could happen. The other areas, because of existing research and because of the actual biological attributes that occur at that site, do not make good sense for those types of manipulations. That's kind of cool, right? All right, so let's come back down here and let's kind of talk about some more of the data management type of stuff. So as of a week ago, we had 3,153 publications generated from research done at the field station. We had a whole bunch of pubs that came in 2015. We have a book written, published in 2016, nice job. And we have a couple of papers in press, some nice work. But I always want to say, oh, no. So the other thing is that one of the things that I've been trying really hard to do, and I often get distracted from, is continuing to work on digitizing the existing historic data sets that a lot of people generally ask for, and they live places, but they're just not always accessible. And so one of those things is, what species occur at the field station? What's been observed? What's the inventory? And so we finally went through Bob's webpage and cleaned up some data sets and cross-referenced, changed names, and species names have changed, things like that. And so we have on the Research Gateway, taxa of Northern Michigan. And so this is a detailed, taxa by taxa list of what's been inventoried at the field station or the region. And so there's a bunch of other forestry data sets like that have also been digitized and put up for use that weren't there a year ago. So if you want to know, all the growth information on the 50-year forestry plots, those are now online. They're cleaned up. They're ready to be used. This is what I was jumping into before. So just because you made a publication, I always, like for my data management workshops, I always show this funny 4-minute video where a researcher tries to go and talk to another researcher about getting the data from their paper. And so the researcher says, well, everything you need to know is in the paper. And so you can just imagine how this conversation goes, because someone wants to use this person's data for their research because they are published in Nature, and so it's a really funny video. I encourage you to Google data management snafu if you have time this evening. But just this idea that, so you publish and you have data, and every year after that publication, the likelihood that that data will be accessible to someone just, and this is not just this isn't a projection, this is actually interviewing people about their publications and whether or not they can then give the person who they're interviewing their data. So I published in 1980, can I have your data for that project? Yeah. I published in 1990. You published in 1990, have data for that project. Maybe, but it's on a Bernoulli disk. Do you have something that will read that? So it's this sort of, this idea that data management and data curation should not be an afterthought for publication, but it should be integral to your workflow as you're writing your publication or as you're doing your research. And that's the end goal, and I'll talk about some things that might help you get there. We're also doing a pretty major overhaul of the Research Gateway. The LTER framework that we use to build our information management system has changed significantly and is no longer supported. And so I've been feverishly trying to get things ported over and changed over in it, and it hasn't been as easy as I thought it would be. So, but probably not this summer, but definitely by this fall, we'll have a new, refreshed information management system. Will have new bells and whistles where you can, interactively look at and graph data in the web page, but it still has all the other functionality that it always had. Looking up PIs and what research sites that they do work at, that kind of stuff. Looking up the data set. So that's coming. So you might not go to the Research Gateway for the next 8 months, and then you might say, oh, that's right, there's that data there. And you might go there, and it might look different than you're used to, and it's because, hopefully, it'll come, because we're trying to revamp the site.
Jason?
Yes?
When you said the LTER data management system is no longer supported, what does that mean? Who supported it?
Okay, so yeah, so we never had much support from LTER in terms of developing an information management system. My predecessor, Kyle Weiser, he met with the folks there and basically said, hey, we are like an LTER. What do you guys do for data management? And I said, well, actually, we're developing this thing. Do you want to help us develop it? And he said, sure, that'd be great. And so we, like probably 10 other LTER sites, we have a Drupal-based ecological metadata management, information management system. And so all that means is that there's this, web-based content management system that we serve all of our data and our research information through. Well, the current sort of structure of that, or the current operating system version, is old and decrepit and no longer supported by the open source community. So it's kind of like moving from Windows 7 to Windows 8 to Windows 10. You know, you got to move to 10 soon because pretty soon they're no longer going to support 7 kind of thing.
So it's not an LTER level decision, it's really the open.
Yes, yeah, exactly. Yeah, no, the LTER is still actively supporting their information management. And, you know, part of their reason for moving, my understanding is part of the interest in moving the office, the information management office, to NC is because they're better equipped to do some of the data management and data science stuff.
So do you anticipate we can still collaborate constructively with LTER?
We definitely are. But I can't go to the LTR information manager group and say, what's the code I use to transform the database schema from this to this? They're like, you're not in the system, I don't have time for you. Go to Stack Overflow. But they're willing to share everything that they create, and they're willing to sort of give some minimal guidance, but they just, you know, it's three information management programmers for the entire LTR system. So, how many times time? Okay.
Keep going. Yeah.
All right. So I showed Raleigh this yesterday, and I had it set up here on the big screen. But we now have within the existing research gateway, we now have the ability for you to search through a GIS interface for data. I just want to sort of see if I can get this all. I'm not supposed to do this, but I always find a way to. So this is a little bit funky here, but what this is showing you is so this is an interactive web map that is projected. All right, so it's essentially showing you, you know, you go into the research gateway and you look through the data, and it says we have data about forestry, we have data about landscape ecosystems, we have data about locations of rivers. It's just kind of abstract, you know, it's a CSV file. So now here it is projected in space. So this is the location of the 50-year plot, and these are the locations of the symmetry for the lake here.
Yeah.
I'm going to change the opacity. So we have the data that's typically sort of locked up in a zip file or locked up in a spreadsheet is now here for you to consume. And so you can see, okay, are there plots within the location of the area that I want to study? Kind of, you know, that's what the intended use of this is. And if you then click on those polygons or those points, those lines, it will take you back to the research gateway to download that file. So the long-term goal is to not have to have you sort of always go and grab data, bring it to your system, but to do a lot of sort of the basic type of viewing, querying, analysis of data just right in the web page, and that's the end goal. So this is one step a little bit further. So now you don't have to bring it to your computer to actually just look at it and see what it is. You can do some of that viewing here. That's the intent. Please. Definitely, yeah. And so then it will all always be sort of linked back to the actual data location within the research gateway.
Jason,
Yes.
as long as we're talking about linkage to other data set. Phil Myers is still here. He was here yesterday. He has an animal diversity website.
Yes.
Is that linked to this?
We do have on the regular web page, we do have a link to the Animal Diversity Web as well as their new app you can put on iOS systems. And I think we showed that off last year where we have 2 structured trail walks and then they have all of the species lists for the station. And so what's neat about that is that I just have to give them a list and then they can populate that list with all their content from their website. So when you're walking down Grapevine Point and you see that you go to this location and it says species in this area, it's not just a list, but then it actually has descriptions and pictures and ways to identify those things. So it's ADW. Yes.
A way to take like a student's chemistry data, work that back over to this go around.
Well, so definitely, so any data set that's in there can be geo-referenced in terms of related to a site. And so think about it this way. So we have this list of sites that are very well geo-referenced, and then they have a database link to the person who collected the data. They have a database link to the data that was collected, the variables that were collected, and the actual data themselves. So yeah. So once you deposit the data into the archive and you start to curate it, you link it to research sites. Yeah. All right, so I just want to say, we also had a presentation last year from someone from SEED, Sustainable Environmental Actionable Data. I think that's a lame name. So, but they're doing really cool stuff. Okay, and so this is not about sort of long-term archival of data, like what our research gateway is intended to be, but this is about real-time collaboration and real-time curation of data. And so this project is neat. It's out of the University of Michigan School of Information, and they're working with researchers. And so it's something where you create a project space. It's kind of like, think about Google Drive with the ability to actually curate the data that you have within Google Drive. It's not just a file structure and it lives in the cloud somewhere, but it's the ability to use semantic web principles to tag and reference things so that you can search for them. It's the ability to link those data to collaborators and their, identification, like an ORCID ID or research ID. And it's nice, and it has the ability to manage and properly attribute all your data sets, and it has the ability to show some GIS data in there. And then they have the ability to then, if you say this data set's well curated, then you can publish that data set the same way in which we can publish a data set by minting a DOI. But there are some, and the nice thing about this is that we were working with them directly to sort of refine and tweak those structures so that the metadata from all the work you do go into curating your data can then be sort of batched right into our system. And that's nice. But they're kind of behind a wall and you can't create your own projects, and they have limitations on the amount of data that you can store there. And so, you can store like a minimal amount of data, but then you reach a certain threshold and then they want you to pay for the service, which is, right, they put a lot of effort into doing that. It's great. But if you don't have the desire to or the ability to pay for this sort of data management, lab-based data management system, then there's another option, which we're going to hopefully pilot with the Profit team this summer, and it's called Open Science Framework. And it's that same model of having a web-based collaborative workflow for data on a research project. But you can link it to your existing cloud infrastructure, so you don't have to pay them to store your data there. So last night I set one of these up for Profit 2016, and then I also established a Profit historic page, and instead of dumping all the data here for people to use, I just linked to the existing mbox folder where all the data lives. And so now people can go into here, they can curate their data, they can share it with collaborators, they can version their data, but they still use the box or the Google Drive or the Amazon cloud to store their data. So they don't have to pay for another external source to store their data. So this is a pretty good option. Yes, Steve?
So is it just, is it storage space limitations, or is it actual lack of functionality from being able to, and thus being able to do it?
Yeah, so the way that it's currently structured and the way that we're structuring it now is not sort of in this direction of real-time collaboration and curation. It's more archival of data, archival of information, and I really don't have the programming chops to do something like this. And so this is sort of a nice intermediate where this is something that's really well put together. It's easy to collaborate with people. It works really well with other applications and other existing functions that we all use out there. You know, a lot of us are forced to use Google by our institutions, and so we use Google Drive because of that. Or Box is a great storage, or Amazon cloud service. All those are things that our institutions are adopting, which, for better or for worse, have been integrated into the way that we do our work now. And so instead of doing something else different now, let's retain that function of using Drive or using Box, and then put it sort of like, not an abstraction, but put another layer over on top of that that allows you to use Box more functionally in sort of like a lab or a collaborative environment. And it also allows you to do that proper curation of your data while you're generating it, so that then you essentially, you know, in the end, we say export XML document, and then we read that into our research gateway, and it fills out all the metadata, and then we grab the file and we put it in the long-term archive. So a place like this, like SEED and Open Science Framework, you know, or most of these systems, even the university's new Deep Blue Data project, they're only saying 5 years. Well, they can only guarantee 5 years, and either by foolishness or whatever, we've said we would archive data through the biostation much longer than that. And so, and I'm committed to doing that. I think Newt and I think everyone else will be committed to storing data longer than 5 years, right? How many of us are using data that's older than 5 years in our projects? Yeah. So as an archive, we're committed to storing it much longer than these types of. Yeah. The other neat thing about this is that you can, and you can do this in JS, but you can do this here. Is that you can say you're doing a project and you publish a paper and you stamp your archive and you register it, and it freezes that in time and creates a copy of it which you can't touch. And that's what you use with your published paper. And then you keep, as that data changes, and you keep adding to it, you keep building on it, in a new publication, then you can stamp that archive and create a new registered stamp. And so you can have version control in terms of, so you're always working in here, in this active sort of project lab space, but then when there's a timestamp and there's a point in time where you want to archive everything and have it be unchanged because that's what you used for your publication, or that's what you used for the document that you, then that's what it is.
What's over here?
That's UMBS is here, and then this is something it's a button that you press. You want to follow me?
Yeah.
We can talk about it in more detail, but essentially what I'm trying to say is that there's really nice functionality for being able to take a snapshot or sort of halt all your data in time at a point in time that's relevant to your project. And using this service, yeah.
But this service is not UFM.
No, it's not.
Password protected.
It is, yeah. I mean, it's very, very safe, and it's.
But last year you just put the
It did, yeah. This wasn't available.
This year, you're afraid of the long-term viability. So next meeting, are you going to tell us that this system is all professional? I mean,
I hope not.
my concern is for security and privacy.
For sure.
Before it gets published, before it gets archived. Yeah. Are these? I mean, I understand that the tremendous functionality, but how do you stop that issue of security for the data that?
For sure. Well, so I feel good about, so the other thing that I feel good about is that all of these spaces that I would like to set up, I'm not actually going to store any of the actual data, the spreadsheets, the outputs from the instruments in this system. We're going to store it in Box here at the university, which has unlimited storage, and it has a very, very, very good level of protection. They're even saying that you can store HIPAA data in Box at the university. That's how secure it is. And we're going to link from this, so there's like this double layer of security. So, and this is all password protected. You can decide what gets seen by the public and what doesn't get seen.
But all curated data is
yeah, so there's this thing that I always have a hard time sort of describing, and there's metadata and then there's data, and so there's the data and then there's the data that describes the data. So all of these systems, no one wants to store your data. No one wants to do that. What people want to do is what institutions want to do, what organizations want to do. They want to give you a mechanism for appropriately attributing and your data, giving it metadata, so that it can be discoverable out somewhere else through some larger discoverability network like Data1. But no one wants to store your data. So in the end, I think that the data will be secure because it's going to be still living here. Really all I had to say. Questions, comments, concerns, feedback? I took a ton of time. I apologize.
Oh, let me apologize. I think this is really valuable. And Steve commented, this is sort of a development. We're really trying to provide this service. And I want to thank you for setting this very clearly and pressing forward. Data archiving and accessibility and protection. So, thank you.
Well, Steve, I just want to sort of say that I'm equally disappointed in the services that are available. I think that our system does a couple things pretty well, but there's a lot of ways in which it's lacking. I think that all of these other sort of web-based workflow, collaboration things, they're great to a point, but so your concerns are real and valid. And will I come back next year and say, there's another new system? The reason why I even said anything about seed is because I knew that it would seem really ridiculous if I came here and said, oh, you should use this now instead of what I said you should use last year. There's still some merits for using that, but there are some real barriers for folks to use it in terms of having to pay for a certain level of service, having to actually get them just to communicate with you to create the project space. This has similar benefits and it has less barriers. Whether or not it's long-term and viable, they are saying 5 years. Yeah, for sure. Thank you.
Thank you, Jason.
Oh, this one I want to show you. So it pops up a little when you select the actual data point on the map. It'll pop up a dialog. It'll take you to that data or allow you to directly just download the JS file. So it's more straightforward. Okay, cool.
Thanks.